Properties of exponents. Today is the first lesson in the radical unit, or also known as Unit 6. And there's two different forms that we are going to focus on today. One is called radical form, and here are three different examples to write down. The second is called rational exponent form. And we'll talk later about how to evaluate each expression in either form. Just know that these two are equivalent, equivalent, and equivalent. And also let's go back to what we know. We know that we often associate the word radical with square root. But radicals don't just have to be square roots, they can also be cube roots, or roots to powers that are higher than 3, like to the 5th root. Rational exponent form. We know the word rational refers to fractions. And so here we have exponents that are written as fractions. The goal today is to be able to take an expression and evaluate it. And we're going to do it without using a calculator. So no phones out and no calculators out. Now, depending on your skill set with multiplication, it may be useful to make a little table that you can refer to for today's class notes and also for homework. So what I'm going to start by doing is we know the ones. We know 1 to the first is 1, 1 to the second is 1, 1 to the third is 1, and so on. But let's start with 2's. So this is 2 to the first. 2 to the second is 2 times 2 is 4. 2 to the third, 2 times 2 times 2 is 8. 2 to the fourth, 2 to the fifth, and 2 to the sixth. Now it doesn't just stop there, but I want us to make a small table and you can continue on. I'm not going to take time to extend this table all the way down, but we will do a few so that we can refer back to it. So this is going to be any number to the first power. The number which we're going to refer to right now is, I'll just leave a number sign there, to the second, to the third, fourth, and fifth power, and lastly 6. Again, it doesn't stop at a number to the 6th power, but for today I know we're not working with numbers with exponents greater to the 6th, since we're just trying to understand the basic concept. So 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, 3 to the fourth power is going to be 81. Now, a quick way to do that is take 9 times 9 and you get 81. 3 to the fifth is 243. I don't think we'll have to go this far, but let's go 3 to the 6th power, which is 729. You'll see as we go through this today, it will be helpful to fall back on this table. We're going to do a few more and then I'll let you do this on your own time. 4 to the first, 4 to the second, 4 to the third, 4 to the fourth is like taking 16 times 16, which is 256. And I know for today we're not going to get into anything that's too big over here. So from now on, and you can fill these in on your own time, I'm going to do 5 through 7 or 8, and I'm just going to keep it between the number raised to the first to the number raised to the fourth. 5 to the first, to the second, to the third power, and to the fourth power is 625. I'm going to just go through 10, actually, deciding that now. And 10, as we've probably all learned in elementary school, is pretty easy. Is when you raise 10 to the power tells you how many zeros need to be attached behind the 1. Okay, so we're going to refer back to this. So I'm actually going to take this right now out of my notebook. You can leave yours in and just flip it back, but it'll make it easier for videotaping for me just to pull this forward. Okay, the first problem we're going to do. So not only do I want you to be able to evaluate the expression, I want you to be able to classify the expression as being in radical or rational exponent. This currently is in radical form, which is easy to see because we can see this shape, which most students previously are going to refer to as a square root. But it's not a square, this is actually a cube root. What does this mean? Without having any other number on the outside, it means what number times itself 3 times equals 25. So I can go back to this chart. I can look into the third column. Oh, there is a number, and the number is 5. That tells me that 5 times 5 times 5 is 125. So the cube root of 125 is 5. Example number 2. Think to yourself, is this rational exponent form or radical form? Okay, so this is radical form. This is the cube root of negative 64. So our only difference now is that our number inside has been changed from a positive to a negative. And that's possible to receive a real answer when the number on the outside referred to the nth root. This is referred to as the nth root. When the nth root is odd, we can have a negative number on the inside and still get a real number. Okay, so I'm looking, forget about the negative for a second and ask yourself, is there a number you can take times itself 3 times and receive 64? So I go back to the chart. I look in the number raised to the third, I'm finding 64. Okay, there's 64. 4 to the third is 64. So initially I'm going to put down a 4. Remember, these numbers must be identical. They can't be different signs. I know a positive times a positive times a positive is going to equal positive 64. I need it to be negative 64. So now let's attach a negative. 3 negatives, or an odd number of negatives, gives you a final answer that's negative, and 4 times 4 times 4 is 64. The correct answer for example 2 is negative 4. Example number 3. Okay, I'd like you to try this on your own. I'm going to give you 20 seconds and then I'll go through it. Okay, so this is the 5th root. This is the 5th root of 32. Go back to your chart. And this isn't very long because I knew that at this point in learning, we're not going to get to these numbers. When we get to these really large numbers, you won't have to have them memorized. We'll start using a calculator at this point. But to begin this process, I want you to understand how to evaluate the expression. So in the 5th, I see 32, and 32 corresponds with 2. So 2 to the 5th is 32. That means 2 times itself 5 times is 32. Correct answer, positive 2. Okay, here's our next one. Example 4. Sometimes this is more confusing for students. This is in rational exponent form. What you have to remember is when you evaluate this, you are always going to start with the bottom number. Always, always begin with the bottom. In rational exponent form, begin with the bottom number. Okay, so there's a couple ways to do this, and I'm going to show you both ways for example number 4. So if I was to evaluate this in rational exponent form, I'd start by asking myself, what two numbers can I multiply and achieve an answer of 36? What two numbers can I multiply and get 36? And if it doesn't pop into your head, again, we're working with 2. I can come back here. I'm looking for 30 or 36 in the squared column, and I get an answer here of 36, and it corresponds to 6. So yes, 6 times 6 is 36. So I've taken care of the 2. I'm going to cross it out so there's no confusion. I know that when I evaluated 36, and I'm going to show you just a little bit how to rewrite this in radical form if it helps you. But if I evaluate the 2 on the bottom, I got an answer of 6. So 6 is the answer to this portion, so I'm going to write 6 down. And now I need to apply the top number. Second, we apply the top number. And this just says 6 to the first power is, and the answer is 6. And if you want to verify your answer, 6 to the first power is 6. So this final answer is 6. Here's another thing to consider, and I'm going to have you put this down in your notes, please. When you see a number raised to the 1/2 power, it's another way to represent the square root. So, 81 to the 1/2, 9 to the 1/2, 100 to the 1/2 have answers here of 9, 3, and 10. In the past, some students would say, isn't it positive and negative 9, or positive and negative 3, positive and negative 10? We're going to get to that a little bit later when we talk about actually solving an equation that has exponents. But if I asked you just what is the square root of 81, your answer would be 9. Here, your answer would be 3, and your answer would be 10. Moving on to example number 5. Okay, so example number 5. We're going to complicate this a little bit for you. And we're going to go back to something you learned last semester. So we just learned that a number raised to the 1/2 power represents taking the square root of a number. But now we have a negative. So before we even talk about that, let's look at something else. Last semester we talked about things like this. We said if you had a to the third, b to the negative 2, and c to the negative 5, and I asked you to simplify this or to rewrite it. Well, if you were going to rewrite this, we wouldn't want to write it with any negative exponents. And so using a very elementary type thinking, we say if something currently has a positive exponent, it's happy where it is. Remember, there's a top floor and a bottom floor, and if it's on the top, which it is, and it's positive, it's happy. If it's not happy, it's going to be represented by a negative exponent, and we're going to move it. A is happy, we keep A where it is. B is not happy, it's on top. It now moves to the bottom and becomes happy. C is not happy, represented by a negative exponent. It moves to the bottom and is now happy. So this is just a review of something we talked about last semester. Now we're going to apply it to this. So what does this look like? Again, we got a couple different ways to look at it. Well, let's go back to what we just talked about 3 minutes ago. Let's first evaluate the bottom. What two numbers multiply what two numbers multiply to equal 144. And a lot of you have already identified that number, but if you're struggling, you go down the list, and we can see that the list stops here. But if I continued, 144 corresponds to 12. 12 squared is 144. So taking 12 times 12, you get an answer of 144. So this portion we just figured out is 12. So I'm going to write a 12 down, and now I apply the top number. That -1 says, hey, 12 is not happy where it currently is. So we're going to move it to the bottom. It's now happy. Remember, we can't put a 0 on top. By placing a 0 on top, the entire expression then would equal 0. So we're going to put a 1 on top, and 12 moves to the bottom. It's now happy, and 12 to the first power is simply 12. That was example number 5. Here's example number 6. Okay, so how do we go about doing this? I want you to think about PEMDAS. Yes, there are parentheses, but there's no immediate work to do in parentheses. If there was work, we would see something like 80 plus 1, or 9 times 9. There's no adding or subtracting or multiplying to do directly with inside parentheses, so can't do any work with parentheses, but there is exponents. So we're going to go ahead and we're going to start with the bottom number. What times itself 4 times equals a positive 81? So I go into my column of n to the 4th, or x to the 4th, and I go down until I find 81. 81 is here. It corresponds with the number 3. That tells me that 3 times 3 times 3 times 3 is 81. And that makes sense because I know 3 times 3 is 9, 3 times 3 is 9, and multiplying 9 times 9, I end up with 81. So this portion gives me an answer of 9. Now I have to apply the 1 on top. I'm still taking care of exponents. 9 to the first power is 9. I have no more exponents. I cross it out. And now the number in front really represents a hidden 1. So -1 times 9 is -9. Final answer. Example number 7. In tomorrow's lesson, we will work on converting radical from radical form to rational exponent form and vice versa. And different students have different preferences on what form they prefer to evaluate an expression in. So this is an example of radical form. The nth root is 6, and we have 5 up above. So what is the order we use to solve this? Just like we have an order with rational exponents, when I have two numbers, one is the nth root and one is a number up above, we always first evaluate the nth root. This is going to be your first step. So I'm going to go to the 6th column, and I'm going to look for what times itself. 6 times equals 64. In the 6th column, right away I get an answer of 64, and 64 corresponds with 2. So 2 to the 6th is 64. So 2 times 2 times 2 times 2 times 2 times 2 gives you 64. That's just inside. I just took care of the inside, and I came up with an answer of 2. Now I apply, the second step is to apply the exponent up above, which happens to be 5 in this problem. So 2 to the 5th. So 2 times 2 times 2 times 2 times 2. And some of you already know the answer. Others will take time to multiply. And others may choose to go to the chart and go, okay, what is 2 to the 5th? 2 to the 5th power is 32. Final answer is 32. Okay, example number 8. In this problem, we're going to take the last 2 or 3 concepts we've talked about. Negative exponents, nth roots, rational form, negatives inside, and we're going to apply it together. So just like we talked about in example 7, we are first going to start with the nth root, or the cube root in this case, of 3. That means what number times itself 3 times equals a negative 125? Well, let's start by looking at the chart. Let's look in the 3rd column, and let's look for 125. Right here, so that means 5 to the 3rd power is 125. But remember, we're not looking for a positive 125, we're looking for a negative 125. So put a negative sign in front, and this works when the nth root is odd, because 3 negatives, or an odd number of negatives, is negative, and 5 times 5 times 5 is 125. So I've evaluated negative 125 to the cube root. The answer inside is negative 5. Now I need to apply the top exponent. There's 2 things I have to do. I have to consider it's negative, and it's the number 2. It's squaring. So first let's talk about the negative sign. The negative says, not the negative 5. This does not determine if the number is happy or unhappy. We do that only by looking at the exponent. So the negative 2 says it's not happy. It's currently on top and it's not happy. So we're going to move it to the bottom. Keep it in parentheses, just how it was. Okay, so it's moved to the bottom. Now instead of being a negative 2, we get a positive 2 with it. And negative 5 squared means negative 5 times negative 5, which is positive 25. Example number 9. Okay, I'd like you to complete this on your own. You have 30 seconds. So you're not going to find 0 or 1 on this chart. We talked about 1, but recognize that 0 to the first, or 0 times 0, or 0 times 0 times 0, or 0 times 0 times 0 times 0 is always 0. Just like 1 to the first is 1, and 1 squared is 1, and 1 times 1 times 1 is 1. So let's start with the nth root. If you take 0 times itself 8 times, you get an answer of 0. So the inside portion is 0. And 0 to the 5th power, so 0 times 0 times 0 times 0 times 0, is still an answer of 0. Example number 10. So back to rational exponent form, and think again of PEMDAS. So there is no parentheses that requires to do work inside, so we're going to go to the exponents. And with the rational exponents, we're going to start with the bottom number. What two numbers, when multiplied, give you an answer of positive 16? The answer is 4. If you're a little unsure of that, you can go to the second column, find 16. 16 corresponds with 4. So I've applied the 2 to this problem, and I now have 4 on the inside. Bring the 3 down and the negative from outside. The second step is we still have exponents to take care of. So 4 to the third power. 4 times 4 times 4. And you could take time to multiply. You can do it in your head on paper. Or since we have this chart, we can go 4 to the third power is 64. So applying the 3 now gives us an answer of 64. And recall that the negative out front is really like a hidden negative 1. Negative 1 times 64 is negative 64. Example 11. Again, this time notice that there's no parentheses that are separating the negative sign from the 16. So this negative sign actually belongs to the 243. So we're going to start with the bottom number and the rational exponent position. What number times itself 5 times equals negative 243? So go to the column. That's a number to the fifth, and we're looking for 243, which is right here. So 3 to the fifth power is 243. 3 to the fifth. So I know if I take 3 times itself 5 times, I get a positive 243. Because it is an odd number, I can attach a negative sign in front of each one of the 3's, and my final answer with an odd number of negatives will remain negative, and 3 times 3 times 3 times 3 times 3 will be negative 243. So this portion is now taken care of, and it gives you an answer of negative 3. Okay, we're going to take this negative 3. I just evaluated this portion. I'm going to put it in parentheses. And now I'm going to bring down the 2. What is negative 3 squared? So negative 3 times negative 3. 3 times 3 is 9. An even number of negatives makes it positive. Example 12. I'm going to give you a full minute to try it. Feel free to try it with your current elbow partner or by yourself. Okay, so what's often confusing for students, and not just working with exponents, is when you see a fraction and the negative sign is in the middle and at the same level as the division sign with your fraction, what does it apply to? Does that negative sign go with the 2, the 3, or does it really mean a negative 2 on top and a negative 3 on the bottom? What I always tell students is take this negative sign, especially when working with rational exponents, and move it up to the top. So I'm going to move the negative up with the 2 and cancel out so there's no confusion. There was only one negative in this problem, and I pushed it up top. So now I'm going to start with evaluating the bottom number. And again, this means what number times itself 3 times equals 27. So I go back to that list. What number times itself 3 times equals 27? So here's 27 in the third column. 27 is associated with 3, so 3 to the third is 27. Again, it's negative 27, and since 3 is an odd number, I can attach a negative sign in front of each one of the 3's. 3 times 3 times 3 is 27. An odd number of negatives makes it negative. So this portion evaluated is negative 3. Now I'm going to bring down the negative 2. The negative 2, the negative sign in front of the 2 says this negative 3 isn't happy. It's currently on top, and I'm going to move it to the bottom. Now it's happy, and I'm going to show that by, instead of writing down a negative 2 as the exponent, I'm going to write down a positive 2. When I evaluate that, 1 remains on top, and negative 3 times negative 3 is positive 9. Examples 13, 14, 15, and 16 are all going to go back to things you learned freshman year, and we may have briefly touched on during Unit 3 in solving, but these are all concepts you learned freshman year. So I'm going to ask you to solve, and in Unit 3 we did talk about complex numbers, so you may have to apply that concept as well. Alright, let's start with the first one. So again, this is going to be example number 13. Your goal is to solve for x. So think of this as like an onion. You're going to peel away all the sides until you're left with just x. So the very outside of this would be the 1/4. And there's a couple different ways to get rid of 1/4 and do it mathematically correct. But the way that's most often taught to you is 1/4 is a fraction, and it's being multiplied by this. So opposite multiplying is dividing. And we often do that, except when it's fractions, we now teach students to multiply by the reciprocal. And the reciprocal of 1/4 is 4/1. And the reason we do that step is the 4's and the 1's are going to cancel out. And they don't just disappear, remember. When they cancel out, really, they turn into 1, because 4 divided by 4 is 1, and 1 divided by 1 is 1. Okay, bring down what we have left. 1 is really underneath the 16. It's hidden. 16 times 4. What is 16 times 4? 16 times 4 is actually 64. So this is 64/1. And I know 64/1 is the same as 64. Okay, we're going to continue to peel away until we get down to just this x. So next I want to get rid of the 2. And there's a couple different ways to do that. So one of the ways you're going to learn is we can raise it to its reciprocal. Raise the exponents to the reciprocal. 2 is the same as 2/1, so the reciprocal is 1/2. The reciprocal is 1/2. But we are going to have two answers here, as we've learned last semester. This is the same, remember, this is the same as taking the square root. So the square root of 64 is 8. Two answers, put a plus or minus in front of the 8. Bring down the x plus 3. And our final step is to move the 3 to the opposite side. To cancel out the 3, we're going to subtract and leave it in front of the plus or minus 8. 1 times adding and 1 times subtracting. That gives us an answer of positive 5 and negative 11. It's always important we plug our answer back into the original problem to check to make sure it works and to make sure there's no extraneous solutions. So we can do this with mental math. Okay, so if I plug in negative 11, negative 11 and positive 3 is 8. 8 squared is 64. 64 times 1 is 64, and 64 divided by 4 is 16. Okay, means negative 11 works. Let's try a positive 5. 5 plus 3 is 8. I don't need to do the work. I can already see that 8 also works. Okay, they both work. Moving on to example number 14. Okay, again, our goal is to solve for x. First step is we're going to get rid of whatever is not touching the x, which is the positive 5. Opposite of adding is subtracting. And again, we can either divide by 1/3 or multiply by the reciprocal, which is much more common, 3/1. The 3's and the 1, even though we say cancel out, remember they really turn into 1's. 12 times 3 is 36. 36 divided by 1 is still 36. Okay, this is going to give us two answers. So the two answers is plus or minus the square root of 36 is 6. We could take the square root or we could raise it to the 1/2 power. Both are correct mathematical procedures. Let's check to make sure this works. Okay, so let's start with positive 6. If I plug a positive 6 in, positive 6 squared is 36. 36 divided by 3 is 12, and 12 plus 5 is 17. That works. If I plug in a negative 6, negative 6 squared is 36, and I know the rest of it works out as well. So both positive and negative 6 work out. Two examples remaining. Okay. 2x squared plus x plus 6 equals 4x plus 11. You may recognize this type of problem from Unit 2 and Unit 3. So you always have the choice of moving things to the left or right. I always suggest moving it to the side with the largest x squared, or the largest, your highest degree. I suggest whatever the leading coefficient is, the largest leading coefficient, move it to that side. So when I move the forward, it's going to become a negative 4. And when I move the 11 over, it will become a negative 11. Nothing's left on the right-hand side. I'm going to combine like terms. 2x squared minus 3x minus 5. Thinking of a number that multiplies to equal negative 10 and combines to give you negative 3. X minus 5 and x plus 2. Combine and multiply. Remember, the biggest mistake I saw students make in previous tests is if the leading coefficient is not 1, you have to remember bottoms up. And our goal is solving right now. So, what is opposite? X equals positive 5/2. And this reduces to 1. And what's opposite of positive 1? Negative 1. And we could take time to plug negative 1 in for x on the left, negative 1 in for x on the right, and we'd see the left side equals the right side. And the same when we do positive 5/2 to both sides. Moving on to our last problem for time purposes. Negative 4x squared plus 2 equals 38. So this is example number 16. Okay, first step is move 2 to the opposite side. Then divide both sides by negative 4. This tells us we will have two answers. So I'm going to choose to square root both sides as a way to cancel out the 2. The two answers in the form are plus or minus, but you can't take the square root of a negative number. So remember that negative comes out front and becomes an I, and the square root of 9 then by itself is 3. Plus or minus 3i.